Hello again. This is a micro lecture. It's going to be on the kind of top two common forces that we've already seen or experienced, whether we realize it or not. As always, you need 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and your follow-up questions on Google Forms. So we're going to start off looking at this book right here. And in particular, we're going to be looking at what are the forces on this book. Well, we've been studying one force in particular, which is weight, or the force due to gravity, and so we know gravity is pulling down on this book. Now, force due to gravity, we can represent the force as an F right here, and we can say that this is the force from gravity by putting a little GRAV, or gravity abbreviation, down here. You could also write out gravity fully, or just put a G, but basically this subscript down here is intended to tell us what type of force this is, or what it's from. Alternatively, we could label this weight, or W for weight, just to represent that this is, again, the force due to gravity, which is the same thing as weight. But this book isn't going anywhere. So if it was just weight or gravity pulling down on this, then we would see the book in free fall, or at least falling of some sort. So we know that the book's not moving. We know it's sitting there, which means there has to be another force kind of pushing upwards that balances this out. You might be like, well, of course, it's the table, which brings us to the next point, which is we have the force from the table pushing up on the book, and what we know about this force is it's actually equal and opposite to the force of gravity, mainly because the book's not going anywhere, so it's not accelerating, which means it's sitting still, and basically these two cancel each other out. So in general, when things are sitting still, there are usually two forces on them. First is the force of gravity, or weight, and the second is the force of whatever it is that's holding them up. It could be a table, it could be the ground, it could be a shelf, it could be a hand, it could be really anything that's holding them up. And anything sitting still, we know those two forces are on it, and they're actually both in the opposite directions and the same size, so they cancel out. So, for example, in this case, if we say that the force of weight is 15 newtons downwards, then we know that the table is pushing upwards with 15 newtons, and that way it cancels out gravity. If the weight of the book was 20 newtons, then the table would push up with 20 newtons, unless it was breaking, in which case it wouldn't push up with 20 newtons, and we'd see the book begin to fall. So here's another example. A man standing on the ground. We again know that there is a force due to gravity on him, as well as the force from the ground pushing him up. These are both equal and opposite, so if his weight is 750 newtons, then the ground is pushing up with 750 newtons. So again, it's the same two forces, whatever the force is due to gravity, and then again, whatever the force is that's holding him up from the surface or from whatever it is he's resting on. One last example. Why don't you pause and see if you can figure out what are the two forces that are on this. So hopefully you paused. Alright, welcome back. So the forces on this apple. Again, we've got the force due to gravity pulling it down, and the force from the hand pushing it up. So anything sitting still basically has two forces on it usually, or resting on something I should say, and sitting still. It has two forces on it, force from weight, assuming it's here on Earth or on some planet at least, and then the force of whatever it is that's supporting it. Alright, one last example. So you sitting on a desk, we've got the feet not touching the ground here, so it's just your bottom on the desk. Go ahead and take a shot at it. Alright, welcome back. And again, force from the desk, so we're using these subscripts here to show that it's from the desk that's pushing up on this person. And as always, we have the force from gravity pulling down on this person. So there's one last important piece of info that I want to tell you about, which is the following. We know that the force due to gravity is weight, so it can be abbreviated instead of writing the subscript down here, which when in doubt, just write F and then whatever is providing the force. But we can simply write this as W for weight. We can also actually abbreviate the supporting force, or whatever it is that's holding something up, as something as well. It's usually often called the normal force, sometimes the reaction force, but it's represented with N. And the reason why it's called the normal force is because it's normal to the surface that whatever the thing is resting on. So normal just means 90 degrees to the surface. So this force is upwards, and it's at a 90-degree angle to the surface that this person is sitting on. And so that's why we call it the normal force. It's often called in, at least like IB physics and higher level physics, not often called this, but sometimes called the reaction force, and we'll talk about what that means a little bit later on. That's it for this one. 3 bullet points worth of notes, a 1 to 2 sentence summary, and do your follow-up questions on Google Forms.